Good morning, fellow humans. And for those in America, good morning. It happened again, another morning. I'm amazed. I just don't know what to do. I was nervous about it. I was worried if the morning would happen, and then about 3 o'clock it did, so it's been a while. Today's ramble is going to be on scintillation detectors. Easy subject, right? Scintillation crystal. The scintillation means that if the crystal, I'm talking about crystals, right? This is going to go into frequencies and resonance and things easily turned into mysticism. So, pardon me if you go there. But scintillation detectors are a crystal that responds to very specific types of energies and frequencies of energies. So this crystal is sitting there in life. This one might have been grown in a cave down in South America, and it probably took millions of years for this crystal to grow. And by grow, I'm not talking about organic growth, I'm talking about crystal growth over millions of years. The soil above where that crystal formed over millions of years leached minerals, very specific minerals, out of the maybe miles of ground surrounding where the crystal formed. And over millions of years, this very precise filtration brought out calciums or whatever other minerals are in those feet, miles, yards of soil surrounding, and created this crystal. This crystal grew, not as organic, not as life, not as thinking, not intentional. It just is what nature has done for us. So we found these crystals, and we learned that they resonate, and they give us specific frequencies that we can repeat and we can use to make radio signals and transmitters and receivers. And it's AM. It's that little plastic radio that came from Japan that first awed the American population so long ago. I was too young to remember it. But that battery operated radio was a hint at the future. So these crystals, these crystal structures, these have a resonant frequency, and it's very specific depending on the purities and the types of the crystals, and this we know about. So what happens further? In looking at these crystals more and more, we learned that they will give off light. They resonate, they fluoresce when certain specific types of particles hit them. This wasn't just a poof, oh my, this was people with a lot of time to research, a lot of interactions among peers discussing these things. So they found properties of these crystals, and one of them happens to be these crystals resonate specifically to energy particles, alpha, beta, and gamma particles that we discovered as part of Madame Curie getting cancer from her work. That's what happens. So these crystals resonate, fluoresce, give off a light. That could be considered ionization because the way the light is given off is by electrons changing orbitals. This is something we understand and know. Every time an orbital changes, there's some energy transfers that happen and can be made into heat. Superconductors are trying to get rid of that heat. by having very low resistance, moving electrons very efficiently without much energy loss in the form of heat. So these crystals are the stuff legends, stories, and religions are made of. Their properties are amazing, and the more we know, the more we do with them. So this fluorescence feature of certain atoms inside those crystals, certain molecular structures of atoms tied together, tell us things if we can see them. And we learned how to see them by staring at a crystal. The previous forms of this, because of the looseness of language in the word crystal, film is this same thing. Film was one of the first tools we used to measure radioactivity. People have seen an ionization chamber with gas vapor in there. That is much the same principle. So this is pieces of a scintillation detector. Now you couple that scintillation detector with something called a photomultiplier tube in the old days. In today's days, you couple that, or actually you build a detector with all these pieces built into it already. It's got some form of artificial intelligence, let's say. It's constructed to tell us something specific and we know about it. So we built a crystal that has specific responses. Now we're going to put this super sensitive light detector called a photomultiplier tube on. Again, there's other equivalents in technology today, but back then this was the thing. This photomultiplier tube with anywhere from 500 to 1700 volts across it in order to amplify photons given off, light given off by the crystals resonating to specific energies. There's more details about the light the crystal gives off, the intensity of that light. We have gotten very good at creating quantums of information from those crystals, the light's given off. So this fluorescence thing is huge. This fluorescence thing is why cesium is used to dope the lenses of night vision cameras, infrared cameras. Cesium, not the radioactive one, the stable one. It has huge valence shells and electrons that move very easily amongst themselves, that create a fluorescence because of the type of energy they release that we can measure with a photomultiplier tube. So I'm right now at 8 minutes on this discussion. To build up to this is I'm at somewhere 140 years of researchers' shoulders. I'm at least 87% correct to this. Only it's not to a technical audience. So, 8 minutes and 30 seconds. Piece is out. One more piece.